Alright, this video is for lesson 1 of the Blended Algebra 2 course, unit 3. This is solve by factoring. If you're working on this lesson and you are noticing that you forget how to factor or you're having trouble factoring, go into the module and click on this lesson 1, and then there will be a ton of practice and videos on all the different factoring methods that we're going to use. You can use those as supplements to this. However, that is not actually part of our course. So you need to make sure that you're staying on pace with the calendar. Solve by factoring is the lesson. So on your own time, if you need extra factoring help, that's what you're going to have to do. So we'll start here with the first problem. We're given a quadratic x squared minus 2x minus 3. That is the graph that is on the screen. All it simply asks you is what are the x-intercepts? The x-intercepts are across the x-axis. So it looks like my x-intercepts here are at -1 and at, looks like 3. So those are the x-intercepts. Now for a parabola, we call the x-intercepts also the solutions and the zeros. There's actually another name. We can also call the x-intercepts the roots of the quadratic. Okay, all of those names, x-intercepts, solutions, zeros, roots, all mean the same thing. It's just another name for the x-intercepts. Now this question follows us down most of the page, but we're going to pause for a second and we'll come back to this graph. We have something called the zero product law. And the zero product law says the product happens when you multiply things. The product of multiple factors is equal to 0 if at least one of the numbers you're multiplying equals 0. So for example, if I have two things that I'm multiplying together that equals 0, at least one of them needs to be 0. So you could have 2 times 0 or 0 times 6, or you could have both of them equal to 0. Alright, so when you multiply things together, if they equal 0, at least one of them has to be equal to 0. That's called the zero product law. And the zero product law helps us solve quadratics. The reason it does that is, we're going to get to the factoring part in a second, but what I have here in A, x plus 7, x minus 3, that's the factored form. So that would happen after you did a method like split the middle or difference of squares. You would get this factored form, and notice that these two factors are being multiplied together, and they equal 0. So because they equal 0, that means that one or both of those factors themselves have to be equal to 0. So what we do in order to find the value of x that makes this equation equal to 0, I have to take each of those factors separately and set them up like little mini equations equal to 0. So each factor gets set equal to 0. And now you solve them both for x. So we're finding the possible x value here that could give us an answer of 0. The first one, I subtract 7, and one of my answers would be that x could equal -7. If x is equal to -7, the whole thing equals 0. If I have 3, so I add 3 to both sides, I get another possible solution that x equals 3. So each factor gives me a value of x that would solve this equation and make it true. We'll come back to what this all means and ties together with in a second. Same thing here, I have 2x minus 5 times x minus 4. Because these are being multiplied and they equal 0, I set each factor equal to 0 in its own mini equation. And then I solve that equation for x. So on the left one here, I would add 5 first, and then I would divide by 2. You can turn that into a decimal if you want, or you can just leave it as the fraction 5 over 2. On the right, all you have to do is add 4, so you're left with x equals 4. Right, each of them, notice, had 2 factors. They each had 2 solutions. Now let's tie this idea back to what we started with. Okay, it says, now let's look back at the quadratic in number 1. So that's this one that was being graphed. Okay, notice, remember, it had x-intercepts at -1 and 3. Same quadratic here. It says they want us to factor and solve this quadratic, find the solutions using the zero product law. Now, what we do when we factor, when we're solving, instead of y here, we turn that into a 0 equals. Right? The reason we want 0 is because at the x-intercepts, what we're looking for, if we go back to our graph, the x-intercepts are along the x-axis. And on that x-axis is where all the y's equal to 0. So I put 0 in for y to algebraically find where the x-intercepts are. So what we're going to do is we'll split the middle. We have a 1 here, and we need two numbers that multiply to -3 and add to -2. I need one positive and one negative. So I'm going to have +1, -3, and we need the opposite, so -1 and +3. The combination that is going to add to -2 is 1 and -3. So what I'm going to do here is I'm going to still keep it 0 equals, but I'm going to split the middle. So I'll have x squared plus 1x minus 3x, and then my last term minus 3. Now I'm going to group the same way that I've been grouping. So I'm going to put the first two terms together and the last two terms together. I still have this set equal to 0. That's not going to change. But now I'm going to divide a GCF out of both terms. So here it's going to be x. So I'll have an x times x plus 1. And in this set, because the third term is negative, I'm going to pull out a negative. Looks like a -3. When I pull out -3, I'm left with x plus 1. Remember, a negative divided by a negative is a positive. Well, my factored form here will give me x plus 1 times x minus 3. Now that's just factored, but now I'm going to use the zero product law to solve this. And remember, we just talked above in the last example that the zero product law says when I have these factors that are being multiplied and they're set equal to 0, in order to find the solutions, each of these factors has to be set equal to 0 because that's going to give me an x value that would solve the solution. So I set them each equal to 0 and I solve them for x. The one on the left gives me x equals -1. And the one on the right, when I solve it, gives me x equals 3. Now the question is, what do I notice about these answers, -1 and 3, and the x-intercepts from up here? Well, notice the x-intercepts up here were -1 and 3, which means that solving by factoring gave us the same answers. So our solutions from the zero product law are the x-intercepts of the parabola, or of the graph. So that's good to know. So when we're finding our x-intercepts, we can find them by factoring. All right, we have 4 examples on the back. We're going to be doing 4 different factoring methods on the back to review. Now, the important thing to remember here is that when you solve a quadratic, because we're finding the x-intercepts for y equals 0, we need to make sure the whole equation is set equal to 0. So on this first one, I have 8x squared equals 24x. I'm going to start by actually moving the 24x over to the left-hand side, so that I'll get 0 on the right. So what I'll have is 8x squared minus 24x equals 0. Now, when I look at this, I have 2 terms. Remember, the first thing you do every time you factor is to look for a GCF. And it does appear to have a GCF here. I can pull out an 8 from both, and they also both have an x. So I'm going to have a GCF of 8x, and inside the parentheses, I'll be left with x minus 3. Now, once I pull out that GCF, it doesn't look like I can factor x minus 3 anymore. So what I'm going to do is I'm going to set 2 small equations up. Each factor that has an x gets set equal to 0. So I have 8x equals 0, and x minus 3 equals 0. To solve this, I just divide by 8. So the first one is at x equals 0. That's one x-intercept and one solution. And then over here, when I add 3, I get my second x-intercept or solution is at 3. So this graph crosses the axis at 0 and 3. And those are the solutions to this quadratic equation. All right, the second one, 4x squared plus 16x again, I need this to be set equal to 0. So I'm going to move the constant over to the left so I get a 0 on the right-hand side. This will give me 4x squared plus 16x plus 7 equals 0. I have 3 terms. I look for a GCF, 4, 16, and 7. Don't seem to have anything in common. So what I'm going to do is go ahead to split the middle here. 4 times 7 is 28. I need 2 numbers that multiply to 28 and add to 16. Because I'm adding to a positive and multiplying to a positive, I want 2 positive numbers. Let's list the factors. 1 and 28, 2 and 14, 4 and 7. The numbers that add to 16 are going to be 2 and 14. So I'm going to split the middle here. The first term comes down. The last term comes down. And I split the middle with plus 2x plus 14x. Now because I split the middle, I now have 4 terms, which means that I'm going to use the method of grouping for the rest of this problem. So from the first group, I pull out a GCF. It looks like I have a 2x in common there. So I pull the 2x out in front, and I'm left with 2x plus 1. Anything divided by itself is 1. In the second group, the third term is positive, so my GCF is positive, and it looks like I'm going to pull out a negative, or I'm sorry, a 7, not a negative, a 7. When I pull out a 7, I'm left with 2x plus 1. Remember, 7 divided by 7 is 1, equals 0. Now what you'll do, remember, these parentheses are the same, which means you factored correctly. So they come down as one binomial. The other binomial is made up of your GCFs, the 2x plus 7. Well, we factored, but we need to solve this equation. And the zero product law tells me to do that, I need to set both of these equations, or I'm sorry, both of these factors equal to 0 in kind of 2 little mini equations. Now I just solve them for x. So I'll subtract 1 from both sides here. I'll get 2x equals negative 1. And I'm going to divide by 2. That tells me that one solution is at negative 1/2. That's one of your x-intercepts. The other guy here, I'm going to subtract 7. And it gives me 2x equals negative 7. And I divide by 2. And that tells me the other x-intercept is at negative 7 over 2, which is negative 3.5. And that's the other solution or x-intercept of my parabola. All right, we have 2 different factoring methods here to look at. All right, so for this problem, there is the polynomial 16x squared minus 25. I always start by looking for a GCF first. 16 and 25 do not have a GCF, and then there's not an x in both terms. So I'm going to try another factoring method. I have 2 terms here, so the only other factoring method that this could be, especially because there's a minus sign here, is the difference of squares. That's a good method as well, because I can take the square root of 16x squared, which is 4x, and the square root of 25, which is 5. Now, if you forget how to do this one, you'll need to go back and look at the factoring mini lessons that are within the module. In order to factor this, we take the 4x on the left in both sets of parentheses, the 5 on the right, a plus goes in one, and a plus goes in the, or a minus goes in the other. Again, we're solving, and this equation from the beginning has been set equal to 0, so we need to set the factor form equal to 0. Now we need to solve, find our 2 values of x that make this equation true. So we're going to set the first factor equal to 0, and the second factor equal to 0. When I solve the left one, I have to start by subtracting 5. I get 4x equals negative 5, and then divide by 4. Here, that solution is negative 5 over 4. You can leave that as a fraction. We do the same thing here on the right. We add 5 to start. 4x equals 5. And then I divide by 4. X is going to be 5 over 4. So I have two options for my solutions, positive 5 over 4 and negative 5 over 4. All right, one more problem on the set of notes here. X cubed minus 5x squared minus 4x plus 20. I look for a GCF, and it looks like there's no number that goes into all of those, and also no x. The last term doesn't have an x, so I don't have a GCF. Now there are 1, 2, 3, 4 terms in this polynomial. When I have a polynomial of 4 terms, the only factoring method that's going to work is grouping. So with grouping, we group the first 2 terms and the last 2 terms together. I look for a GCF for both sets of terms. So in this first term, first set of parentheses, my GCF is x squared. So I'm going to factor an x squared out. And left inside the parentheses is going to be x minus 5. The second set of parentheses, notice the third term is negative, which means you're going to factor out a negative in both. It looks like the number is going to be negative 4. So I factor out a negative 4, and I'm left with x minus 5. And this is all equal to 0. So I write this in factored form. The x minus 5 comes down, and then x squared minus 4. Remember, you pull the terms from in front. Now I'm almost done, but when I look at this, I'm actually not quite there. I have a little bit more work to do, because this x squared minus 4 factors further. X squared minus 4 is going to factor just like the previous problem with the difference of squares. So when I factor this again, I need to take the square root of x squared, which is x, and the square root of 4, which is 2. This factored form then becomes, again, we're refactoring, or factoring more, what was in yellow up above, the x on the left with 2 on the right. We have a positive and a negative. Now this other factor, x minus 5, still stays there. It is still part of the solution to our polynomial. So we're going to take this. We have 3 factors now. And remember, the zero product law says to solve this, you take each factor and set them equal to 0. Because that's going to allow us to find possible x values that make the equation equal to 0. Now I solve each one. We start by adding 5. So I get one solution is 5. This solution here is negative 2. And the last solution tells me that I could have an x value of positive 2. So there are 3 solutions to this problem. All right, there are 2 practices actually on solving quadratics by factoring using the zero product law. So try those. There'll be little practice videos, and the key is on posted as well.